Imagine you are standing outside, right in the middle of rural Alaska, in the dead of winter. It is just completely freezing.
Oh, yeah. Like bone-chilling cold.
Exactly. And you're looking out at this vast, snow-covered landscape under a night sky. Now, picture two people standing side by side, looking at that exact same view.
Okay, I'm picturing it.
So the first person looks out and sees a really pretty, albeit freezing, picture. Like they see a beautiful starry night, a white snowy field, and they just feel a cold breeze.
Right. They're just taking in the aesthetics of the landscape. It's a familiar place, maybe slightly intimidating to them.
But the second person standing right next to them looks up and notices that the stars are fluttering, like twinkling really rapidly.
Which is a huge detail to catch.
Yeah, and they look down at the snow and see that the drifts are messy and erratic, and they can feel that the wind carving those drifts is coming from the west.
Ah, so they aren't just looking at a view.
Not at all. Because of years of community experience, that second person is reading a highly detailed survival map and a weather forecast.
Wow.
Yeah, they know just by looking at the twinkling stars and the messy snowdrifts that a severe storm is coming tomorrow, and that the erratic west wind brings bitter, dangerous cold.
I mean, that is an incredible contrast to witness. One person just sees this static picture, right? But the other person is actively reading a dynamic, data-rich environment.
Exactly. That second person is doing something that, well, a lot of us have largely forgotten how to do. They are reading the Earth. And today, for our deep dive, we are looking at a framework from Alaska that is trying to teach us how to get that skill back.
Right. It's called Cultural Standard B.
It is, and it's a fascinating framework. The sources we have today are a stack of educational frameworks, ecological research, and community-based science guidelines from Alaska.
And they all kind of point to one central idea for you, the listener, whether you're a student, an educator, or just, someone trying to understand your place in the world.
Which is such an important mission.
It really is. And that central idea is simply this. We all learn from somewhere.
Yes. And I feel like there's sometimes this misconception that local knowledge, like knowing how to read those stars or those snowdrifts, is somehow a lesser form of knowledge.
Oh, absolutely. People often treat it like it's just this cute stepping stone until you get to the real academic learning in a textbook.
Right. But what blew my mind in these sources is how explicitly they reject that idea.
Yeah.
Local knowledge is actually a highly sophisticated empirical science of place.
It really is. It's a rigorous foundation for interpreting the world, for solving complex problems, and, learning completely unfamiliar ideas.
So if we accept that reading the stars is a science, how does a school actually teach that alongside, say, math and reading?
Well, that's exactly the gap Standard B is trying to bridge. It establishes a set of rules, or like a blueprint, for how a culturally knowledgeable student connects their local world to the broader universe.
And the text breaks this down into 4 essential pillars. Let's look at the friction behind these, because they aren't just easy bullet points to memorize.
Right, they challenge the status quo.
Definitely. The first pillar states that you should be able to learn from other cultures without weakening or dismissing your own.
Which is a massive challenge. I mean, historically, education systems often operated on this model of replacement.
Yeah, like assimilation.
Exactly. The assumption was that to learn the dominant culture's way of doing things, you had to just leave your own culture at the door. But Standard B demands an additive approach.
An additive approach. I like that.
Yeah, you add new knowledge. You do not trade your identity to get it.
Which feeds directly into the second pillar, right?
Yeah.
Using the knowledge, skills, and ways of knowing from your specific community to understand the larger world.
Using home as the lens to view the globe.
Exactly. Like, if you understand the complex tidal systems of your local inlet, you can use that foundational understanding of physics and gravity to understand lunar cycles anywhere in the world.
That makes perfect sense. And then the third pillar requires you to consider the long-term consequences of your choices.
Yeah.
It pushes that time horizon out much further than we typically do in modern society.
Right. We'll get deeper into that later, along with the fourth pillar, which asks you to select technologies by considering whether they actually improve community life.
Instead of just accepting them blindly because they're new.
Exactly. But first, I really want to focus on where this foundation actually comes from. Because, this local knowledge isn't just handed out in a syllabus on the first day of school.
Oh, definitely not.
Looking at our sources, this knowledge is born from deep, continuous observation over time. It comes from family and community experience, from the heritage language itself,
From deep ties to the land and water, too.
Yeah, and from daily occupations, cultural practices, stories, and teachings from older generations.
And we can't forget trial and error. I mean, you have to remember the stakes here.
Right, I kind of think of this accumulation of local knowledge, like a multi-generational open-air laboratory. Except in this lab, survival literally depends on the accuracy of your data.
Exactly. If you misread the ice or the wind, the consequences are immediate and severe.
Yeah, you don't just fail a quiz.
Right. And what's crucial to understand about this open-air laboratory is that the knowledge it produces is not some static relic of the past.
Like it belongs in a museum or something.
Exactly. It is constantly adapting to changing conditions. It's a living system.
Hmm.
When an elder teaches a younger generation, they aren't just reciting a script from 300 years ago. They are passing down an actively updating database.
Well, let's talk about the specific data points these communities are tracking, because we aren't just talking about someone saying, like, oh, it feels colder today.
No, it's way more precise than that.
Right, we're talking about hyper-specific biological triggers. Like, forget the calendar on your wall for a second. The sources talk about phenological clocks.
Right, phenology, the
Yeah.
study of cyclic and seasonal natural phenomena.
Yeah. Instead of tracking days on a piece of paper, communities track the physical changes in plants and animals to know exactly what season it is.
And the application of that is entirely practical.
Take the fireweed plant, for example. Our sources talk about how Chugach elders read the fireweed as a seasonal clock.
Oh, I love this example.
It's so cool. So when the fireweed flowers start blooming at the bottom of the stalk and move upward, that means summer is progressing. But once the top flowers bloom and the bottom blossoms turn to seed, that visual data cue signals that fall is imminent.
It's so precise, and you see this mirrored across the entire ecosystem.
Like with the bears, right?
Yeah, the emergence of the skunk cabbage in the spring is a direct indicator that brown bears are leaving their winter dens. It's basically an alarm clock for bear safety.
Wow. And you even see this embedded in the language itself. The Yupik calendar names months based on environmental shifts rather than, arbitrary historical figures.
Like Julius Caesar. Or
Exactly. The month of April is called Tegnirvik, which translates directly to the time that birds come.
I mean, that is just a much more functional way to organize time for a subsistence community than the Gregorian calendar.
It really is. But my absolute favorite example from the text is observing cottonseed hairs flying on the summer wind.
Oh.
Because for most of us, that's just a pretty summer breeze. Maybe makes you sneeze. But for local communities, that is a biological signal that the wild salmon run is beginning, which means it is time to prep the set nets and get the drying fish camps ready.
And the adaptability of this knowledge becomes so vital today because these precise, traditional indicators are currently tracking rapid climate change.
Right. The environment is shifting beneath their feet.
It is. The data is literally changing. Our sources note that elders in Toxic Bay are observing that crowberries, Empitrum nigrum, are turning brown and ripening much faster than they used to due to intense summer heat.
Because the summers are just getting hotter.
Exactly. And because they are actively observing these anomalies, families are forced to adapt their traditional harvesting times. The database updates.
Okay, I get the romance of this. I really do.
Yep.
But realistically, I have a supercomputer in my pocket. I have a weather app tied to a billion-dollar global satellite network. Why do I need to look at snowdrifts or cotton seeds anymore? Like, why is it so critical to maintain this localized observational knowledge when we have all this technology?
That is the most common critique, but honestly, it completely misunderstands scale and relationships.
How so?
Well, broad-scale scientific models and satellites are incredibly useful, obviously, but they often miss the highly localized relational anomalies that happen in a specific habitat over decades.
Oh, okay.
A satellite can tell you the overall temperature of a region, but a local observer tracking an ecosystem across generations can tell you how a subtle shift in wind patterns changes the shape of the snowdrifts, which in turn affects where the caribou bed down, which impacts the hunting season.
So they see the entire web of relationships.
Exactly, whereas the satellite just sees, a heat map.
That makes a lot of sense. And because local observation catches those granular things that satellites miss, we really have to look at how these different knowledge systems interact. We're talking about Western science and indigenous knowledge, or traditional ecological knowledge, which we often see abbreviated as tech.
And it is vital to understand how they differ, because they notice different things, they ask different questions, they use different forms of evidence.
And they serve different purposes.
Yeah, with different limits.
Think about how you, the listener, probably learned biology in high school. You likely took a frog, put it on a metal tray in a brightly lit room, and dissected it to figure out how its organs worked.
A classic high school experience.
Right. And that is Western science. It's reductionist. Which doesn't mean it's bad. It means it works by isolating specific variables in controlled, often short-term studies to find precise causal mechanisms.
It tries to disconnect the observer from the observed to remain objective.
Exactly. But indigenous knowledge, or tech, is watching that frog in its pond for a decade.
Yes. It's holistic, it's intergenerational and deeply place-based. It doesn't separate the observer from the environment.
It views humans as active participants within an ecosystem.
Exactly. Its value system is governed by respect, reciprocity, and stewardship. Its purpose isn't just to gather data for academic curiosity. Its purpose is literal survival and community well-being.
Which means these systems are not automatic opponents. They shouldn't be competing. They should complement each other. The sources call this the two-eyed seeing approach.
I love that phrase.
It's great, right?
Yeah.
You learn to see with the strengths of indigenous knowledge with one eye and the strengths of Western science with the other.
And we see a fantastic real-world application of this in the Ikavik Sikukun project, the Ice Bridges project in Hotsubu Sound.
Oh, man. This is a perfect example of how the methodology itself changes when you combine these systems.
It really was.
So university researchers wanted to study the Arctic. Usually scientists just fly in, set up their instruments based on their own academic models, and leave.
Right, very top-down.
But in this project, they collaborated directly with the local tribe from the very beginning.
And because of that, the local hunters' intimate, long-term observations of sea ice dynamics and the specific resting behaviors of bearded seals, the Ugruk directly informed the scientific questions being asked.
So the researchers might have wanted to measure ice thickness generally, but the hunters pointed out that the seals utilize very specific shifting ice formations.
Exactly. The local knowledge designed the methodology. The hunters knew exactly where and how to look.
The two systems supported and extended one another to create a much more accurate picture of the Arctic than either could have achieved alone.
But integrating systems like that requires data compatibility, which means we have to navigate some very strict ethical boundaries regarding how that knowledge is shared and used.
Because there's a right way and a very wrong way to engage across cultures.
The sources are very clear on this. If you are learning or teaching across cultures, you must proceed with humility.
You have to build genuine relationships with the community. You must give proper credit and authorship to the knowledge holders.
And most importantly, you need free, prior, and informed consent. Yes. You do not coerce, and you ensure the community knows exactly how their knowledge will be used before they share it.
That is the ethical standard. The biggest mistake, the wrong way, is taking knowledge out of its ecological or moral context. You cannot treat culture as a superficial decoration.
No, absolutely no.
Like you can't just put a tribal pattern on a math worksheet and call it culturally responsive. That's tokenism.
And another major pitfall is pan-indigenization, assuming all native communities are the same.
Oh, right. You can't take a lesson designed around Tlingit coastal rainforest traditions in Southeast Alaska and just drop it into an Athabascan classroom in the boreal forests of the interior.
Because they are completely different ecosystems with different languages, histories, and practices.
It also means respecting boundaries. You never use sacred or restricted family knowledge without explicit consent.
Never.
Because if you take a piece of local knowledge, like a traditional story about an animal's migration, and rip it out of its cultural and ethical context, it's like trying to run a brand new smartphone app on a computer from 1995.
That's a great analogy.
Right. The data is still there, but the environment needed to execute it is completely gone. And because it won't run on their system, people from the outside just dismiss it as a myth or a fairy tale. It completely loses its original functionality.
And part of respecting that operating system is recognizing how it transmits data. Treating traditional stories as mere folklore strips them of their empirical validity.
They're not just fairy tales.
No, these stories are highly sophisticated encodings of survival-critical biological data, meteorology, and ecological histories.
So when a story talks about a certain animal's behavior during a specific moon phase, it's actually conveying vital generational data about resource management and safety.
Exactly. And stretching that timeline out connects us back to the final components of Standard B consequences and technology.
Because protecting the integrity of local knowledge naturally leads to how communities protect their futures.
Right. Standard B requires us to consider the long-term consequences of our choices.
So, listener, I want you to imagine a choice you or your community is about to make regarding your local environment. Stretch the consequences of that choice along a timeline. What happens tomorrow?
What happens next year?
What happens 10 years from now?
What happens for the next generation?
That time horizon is fundamental to traditional ecological knowledge. Tech inherently contains built-in resource management practices. They aren't just harvesting to eat today.
Right. The practices are designed specifically to maintain the ecosystem's carrying capacity so that resources remain abundant for the generations that haven't even been born yet.
It's the ultimate long game. And that long game perspective completely changes how we interrogate technology. Standard B asks us to view technology not as an automatic, unquestionable improvement.
We have to evaluate it strictly as a tool.
And to evaluate it, we have to ask some very critical, sometimes uncomfortable questions about any new piece of tech introduced to an environment.
Because it's not always a net positive.
No. So if someone brings a new technology into your community, ask yourself, who actually benefits from this?
Who pays for it?
Who is responsible for maintaining it?
What traditional knowledge or skill might this new technology replace or erase?
Yeah, like if we start relying entirely on GPS screens to navigate the tundra, do we lose the ability to read the east and west wind snowdrifts?
And what new dependencies might this technology create for the community if the satellites just go down?
Ultimately, the most important question is, does it actually strengthen community capacity and well-being? If the answer is no, then the technology might not be a step forward at all.
Exactly. Local knowledge, learning to read the environment, understanding your community systems, none of this is just about preserving the past for the sake of nostalgia.
It is a rigorous, adaptable toolkit for navigating the present and designing the future.
The central message we want you to take away from this deep dive into Alaska Cultural Standard B is this: knowing where your knowledge comes from does not close the world around you.
It gives you somewhere solid to stand while you explore it.
It anchors you so you can reach further.
So next time you are learning a new skill, or maybe adopting a new piece of technology, ask yourself, what invisible assumptions are built into this tool, and what local knowledge of your own are you trading away to use it? Will you still be able to look up and read the warning in the fluttering stars?
Thank you so much for joining us as we explored this framework.
Thanks for listening to this deep dive. See you next time.